Time to do a little math.
Okay, so we got this function 3 to the x. Any graph, we really can just make a table if we center these values. That's kind of a good starting point. And so we'll use order of operations here. So if I want to do this, I do 3 to the 0, which is 1. Say 1. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. And I can go and I can keep doing the negative ones. Remember that these are not just like times a negative, right? Those are valuable things to know about multiplication, but these are exponents. So they follow some different properties. Middle step that I might not have shown here would be 1 over 3 squared, okay? You might notice a little pattern in this, in that as we go this way, everything's going times 3. So that's like a nice, easy pattern. And as you reverse that pattern, you go the other way, it's like divide by 3. And so I'll show that on the next graphs kind of how you can implement that strategy. But let's go ahead, we're gonna go ahead and plot some of these points. Remember, these are points that are on the graph. These are x, y coordinates. So like 0, 1. Now I'm gonna scale this, I'm gonna put 1, 2, 3, 4, 5. Okay, I'm just counting now. 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I didn't even need to go that far. So I'm gonna plot some of these points here. We get 0, 1, 1, 3, 2, all the way up to 9. Notice I'm not gonna get the 3 there. And these points over here, they're gonna be really hard to do accurately. But what we need to know is that as we go more negative, this y value is getting smaller and smaller. So I'm just gonna say, hey, it's getting close to 0. It's never gonna cross 0 because if I keep cutting it into thirds, it gets close to 0, but never quite 0. So this is gonna be a pretty accurate graph, okay? I got my points plotted here. These don't have to be accurate. And I just need to make sure that I also do not cross the x-axis. So I want to make sure that this does not cross. To show this pattern that's happening here that I didn't fill out a table for, but it's what's happening is that these are getting smaller, okay? So as we get to a graph like this, 2 times x, 3x to 3 to the x, there's a coefficient. Now we can't combine these. That's not something we can do because of order of operations. Multiplying has to happen after exponents. And so in this case, we'll have 2 times 1, and we get to 2. Now, what I want to point out is, I'm going to show the work here a little bit more. But I want to show you something that's kind of nice. Each time is just, as the exponent increases, it's saying times 3 one more time. So really, I can just tell you times 3, and then times 3 one more time. So each of these are just a multiplier of 3. And just like I did on the other graph over here, to go backwards, I'll divide by 3, which might seem a little tough with like this, but don't worry, we can just leave them as fractions. We're gonna say 2/3, 2/9. So when you divide a fraction by a number, so as I go this way and I divide by 3, you can just triple the denominator. So let's get to this graph. Again, I'm gonna scale up, so I'm gonna go by 1. So 1, 2, 3. Obviously, I don't need as much x and y axis there, but now the y-intercept is at 2. So that's kind of a nice starting point. And then at 1, I get 6. And clearly, I'm not going to get this other point on the graph. So what I want to make sure is that when I draw this side, I'm showing, it's not a straight line, but it's a big steep curve. And then now let's go down. So this is going to go here. Again, I'm just approximating, and I might not get it accurate, and that's totally fine. But what is important is that I show that it's flattening out here. So I got this nice little curve here. Just a couple key points, like 1,6 and 0,2. That's all we really need there. So what happens when we get something like a quarter? So I'm gonna burn through this a little bit quicker now. Even if it's a quarter or a fraction, to the 0 power, I'm still gonna get 1. The difference now is like multiplying by 1/4 is the same as dividing by 4. So I'm gonna have a 4th, a 16th. So like, look, the denominator is just timesing by 4 each time. 1/64. And the other direction I can multiply by 4. This is a great example where I'm only gonna get 2 of these points accurately plotted, okay? I mean, I could get more if I probably just gonna get 2. So again, I'm gonna go by ones, 1, 2, 3. And it's gonna be one of the negative points that I end up getting accurately. And the other side's gonna be what kind of tails off. So notice this is similar to our other graph. The difference, and so I'm making sure that this is clear that it's not even getting up to 16. The difference being that it's going this other direction now. I want to make this nice. I'm going to say 1, just show that it's 1, 2, 3. Okay. So again, our little hint with this, when there's a coefficient here, kind of the quick spot to start is, again, we could plug it in. And while anything to the 0 is 1, but that 0 is only applying to the 1/2, not to the 8. So this is just going to be 8. And then this number shows what we can multiply by. So multiplying by 1/2 is the same as dividing by 2. And the other direction, we double. So again, use that pattern for yourself, okay? So as I'm timesing by 1/2, and then this direction, I'm dividing by 1/2, which is the same as times 2, right? Keep flip switch. If I switch this to a multiply, I flip this, which becomes 2/1. And so if I want an accurate graph, I might scale this guy up a little bit differently. I'm gonna scale this one by 2s. So I'm gonna go 2, 4, and it's up to you how you scale it. Again, I only needed a couple points on here, but if I wanna get a lot of points on here, and don't forget, you can scale your X and Y axes different. So here we go. So 0, 8, here's that point right here. So I just plotted that. 1, 4, 2, 2, 3, 1. So that's where that's trailing off. -2, and oops, I don't know what I just did here. That was a weird call. If I'm going by 2s, I think I just started looking at these values. This should be 10, 12, 14, 16. Okay, there we go. So ignore those points right there. 16. And I'm still not going to get that -2 point in there. Oops, sorry, I missed. So let's sketch it in. All right, a little ugly because I messed up a few times. That's just a rogue point I missed. So what happens if we have a negative coefficient? That's a negative, right? Well, it's going to be very similar. The difference now is that when I do this, I'm going to end up with a negative. I'm going to end up with -2. This becomes 1. So I'm left with -2. So all these numbers are going to stay negative because I'm multiplying by a negative in the end. Here's my multiplier. So I'm going to go -8. Because each time I'm going to multiply by 4. -32. -124. Nope, that's not right. -128. There we go. And then these ones I would divide by 2. So it'd be -2/4, or 4, sorry, divide by 4, and -2/16. These could have been simplified, but I just want to show clearly what's happening. So again, as we go this way, it's like times 4. And the other direction is like divide by 4. So like, I'm probably only going to get these 2 points plotted accurately. So I'm going to go 1, 2, 3. Okay, so I'm going to plot 0, -2. And this goes 1, 2, 3, 4. So notice now it's in the negative region. And -1 or 1, 8. And the next one's not going to reach. I'm going to kind of eyeball these ones. So at -1, I get to half. And this time, I'm still getting close to 0. The difference is that it's coming from the underside of the x-axis. In case you forgot, this is the x-axis. So let's check out this one. Similar idea. I'm going to show kind of from this point. I would get -5. And so I get 1/5. All right, so that'd be, each time I'm going to go -1, -1/5, -1/25. And on the other end, I'm going to multiply by 5. 25, -1/25. So clearly, again, I'm only going to probably get these points accurately. These will fit on the graph, but they're not really accurate, and that's okay. So 1, 2, 3, 4, 5. So let's plot some points. And again, this is going by 1, 2, 3, 4, 5. So let's get 0, -5. 1, -1. Okay, these were negative, sorry. I mean, clearly they are. And then I'm showing that I'm getting close to the x-axis. And I'm not going to even get this -1 point. I'm just going to show that this is like way steep. And here's a pretty good graph. Don't cross the axis. We got there.